Have you ever walked outside on a hot summer day and felt like you have just stepped into a sauna? The air can feel thick, heavy, and incredibly warm, making you feel sticky almost immediately. This feeling is not just about the temperature shown on the thermometer, it is about something else in the air, humidity. On these days, even a short walk can leave you feeling tired and sweaty, as if you have run a long race. Understanding why this happens is all about science, and it all begins with the amazing way our bodies keep themselves cool. It is a fascinating process that involves water, air, and your own personal cooling system. The difference between a hot, dry day and a hot, humid day can be enormous. Imagine two cities with the exact same temperature, say 30 degrees Celsius. In one city, the air is dry, and while it feels hot, you might find it quite bearable. You can sit in the shade and feel a pleasant breeze. In the other city, the air is filled with humidity, and that same 30 degrees feels suffocating and much, much hotter. This extra hot feeling is what scientists call the heat index, which combines temperature and humidity to tell us how hot it really feels to our bodies. So, what is this mysterious thing called humidity that can so drastically change our comfort? Let's consider an example you might know. Think about boiling a kettle for a cup of tea. As the water boils, you can see steam rising from the spout. This steam is water in its gas form, known as water vapor. Now, imagine that same invisible water vapor all around you in the air. That is essentially what humidity is. When there is a lot of it, we say the humidity is high. When there is very little, the humidity is low. This invisible water in the atmosphere plays a huge role in our weather, and more importantly, in how we experience the temperature on any given day, making some summer days feel wonderful and others feel rather oppressive. This feeling of being in a sauna is more than just a feeling. It has real effects on our bodies. High humidity makes it harder for us to cool down, which can be dangerous if we are not careful. It is why weather forecasts often mention the humidity level along with the temperature. They are giving us a crucial piece of information about how we should prepare for the day. Should we drink extra water? Should we avoid strenuous exercise outside? Understanding the science behind humidity helps us answer these questions and stay safe and comfortable, even when the weather feels like it is working against us. It is all about the cool science of staying cool. So, let's break it down. What exactly is humidity? In the simplest terms, humidity is the amount of water vapor that is present in the air. Water vapor is just water that has turned into a gas. This happens all the time through a process called evaporation. Water from oceans, lakes, rivers, and even puddles on the pavement gets warmed by the sun and rises into the atmosphere as an invisible gas. You cannot see it, but it is there, mixed in with the other gases that make up the air we breathe, like oxygen and nitrogen. The more water vapor there is in the air, the higher the humidity is. When we talk about humidity on a weather report, you might hear the term relative humidity. This sounds a bit more complicated, but the idea is still quite simple. Air can only hold a certain amount of water vapor at a specific temperature. Think of the air as a sponge. A warm sponge can hold more water than a cold sponge. Relative humidity tells us how full the air is with water vapor compared to the maximum amount it could possibly hold at that temperature. So, a relative humidity of 100% means the air is completely saturated. It cannot hold any more water vapor. It is like a soaking wet sponge that is dripping water. This is why humidity is often higher in places near large bodies of water, like coastal cities or tropical islands. There is a constant source of water ready to evaporate and fill the air. Conversely, places far from water, like deserts, tend to have very low humidity. The air in a desert might be incredibly hot, but because it is so dry, it feels very different from the heat in a humid jungle. The lack of water vapor in desert air means it has a lot of room to absorb more, which is a key part of the story of how our bodies stay cool. This difference is central to understanding our comfort. It is helpful to think of the air on a humid day as being crowded. Imagine a busy room where people are trying to move around. If the room is already full of people, it is very difficult for anyone else to enter. In the same way, when the air is full of water vapor, high humidity, it is difficult for more water to evaporate into it. This simple fact has a massive impact on one of the most important functions of our bodies, sweating. The effectiveness of our built-in air conditioning system depends entirely on the air's willingness to accept more water, and on a humid day, the air is not very cooperative at all. Our bodies are incredibly smart. They have a built-in automatic cooling system that works to keep our internal temperature stable, right around 37 degrees Celsius. When we get too hot, whether from exercising or just being in a warm environment, our brain sends a signal to millions of tiny glands in our skin, called sweat glands. These glands then do their job. They release sweat. Sweat is mostly made of water, with a little bit of salt and other minerals mixed in. This liquid appears on the surface of our skin, and this is where the real magic of cooling begins. It is a simple yet brilliant biological process. The process that cools us down is called evaporation. For the sweat on your skin to cool you, it needs to turn from a liquid into a gas, water vapor. This change requires energy, and it gets that energy from your body in the form of heat. As the sweat evaporates from your skin, it takes some of your body heat with it, carrying it away into the air. This is why you feel a cooling sensation when a breeze blows over your damp skin after a workout. The moving air helps the sweat evaporate faster, which in turn cools you down more quickly. It is your own personal air conditioner. Think of it like this: if you spill a little water on a table, it will eventually disappear. It has evaporated into the air. If you point a fan at the puddle, it will disappear much faster because the moving air speeds up evaporation. The same principle applies to your skin. On a hot but dry day, the air has very little water vapor in it. This means there is plenty of room in the air for your sweat to evaporate into. Your sweat can easily turn into a gas and float away, taking your excess body heat along for the ride. Your cooling system works perfectly and efficiently. This process of evaporative cooling is extremely effective, but it has one major weakness. It depends entirely on the condition of the air around you. Your body can produce all the sweat it wants, but if that sweat cannot evaporate, it cannot cool you down. It will simply sit on your skin or soak into your clothes, making you feel wet and uncomfortable without providing any of the cooling relief you need. This is the critical point where humidity enters the picture and begins to cause problems for our very clever internal thermostat, turning a manageable hot day into a sticky and sweltering ordeal. Now we can put all the pieces together to understand why humidity feels like a sauna. On a hot, humid day, the air is already crowded with water vapor. Remember our analogy of the air being like a sponge? On a humid day, that sponge is already nearly full. Because the air is so saturated, there is very little space left for any more water to evaporate into it. This creates a major problem for your body's cooling system. The sweat that your body produces to cool you down cannot evaporate easily. It has nowhere to go. The air simply will not accept it. Instead of evaporating and carrying heat away, the sweat just stays on your skin as a liquid. This is why you feel so sticky and damp on a humid day. Your clothes might feel heavy and wet, and you might feel like you are constantly covered in a thin layer of moisture. You are sweating, and your body is trying its best to cool down, but the process is incredibly inefficient. The sweat is not doing its main job of evaporative cooling. As a result, your body heat is not being removed effectively, and you continue to feel hotter and hotter, even if the actual air temperature has not changed. Let's contrast this with a hot, dry day, like you might experience in a desert. The temperature could be even higher, perhaps 40 degrees Celsius. However, because the humidity is very low, the air is thirsty for water. As soon as you start to sweat, the dry air quickly absorbs it. The sweat evaporates almost instantly, pulling heat away from your body so efficiently that you might not even feel very sweaty. You are still sweating a lot. In fact, you are probably losing a lot of water. But the cooling process is working perfectly. This is why a 40-degree day in a dry climate can feel more comfortable than a 30-degree day in a humid one. In summary, humidity dramatically changes how we perceive heat because it interferes with our primary method of cooling down. Our bodies rely on the evaporation of sweat to regulate our temperature. High humidity slows this process down to a crawl. The heat stays trapped close to our bodies, and the sweat just sits there, making us feel sticky, clammy, and much hotter than the thermometer reading would suggest. So, The next time you step outside and the air feels thick and soupy, you will know exactly why it feels like a sauna. It is all about the science of sweat and that invisible water in the air.